to all. Good afternoon to everyone.
Good afternoon, sir.
Good afternoon.
Good afternoon,
So,
sir.
yeah, good afternoon. So we will start the process, and we will try to look into some more aspects of error control process and how the calculation has to be proceeded further with the equations. So we have seen that the equations, these are the things we discussed in the previous class. We have started with a steady state error and error constants, nonlinear sources, and all these things we have seen. Further, to move ahead with, we have also gone with the equation ESS is equal to limit of t tends to infinity r of t minus c of t, and we have also written a few equations that transfer function is c of s by r of s g of s divided by 1 plus g of s h of s. So all these things we have done, and we have also come out with the equation for steady state error, that is ESS is equal to limit of s tends to 0 s of r of s divided by 1 plus g of s. And we have seen with respect to the first case, that is a unit step function. So unit step function, we got r of t is equal to u of t, and ESS is equal to 1 by 1 plus kp. So these are the things what we have understood till date, and we also got kp is equal to limit of s tends to 0 g of s, which is called as a positional static error constant. So till here all of you understood the things. So here the major important equation is ESS is equal to 1 by 1 plus kp. So that is the equation we are going to see further. So it's clear for all of you till here. Shall we proceed with type 0, 1 and 2?
Yes, sir.
Okay. What we can see here is now we are going to see the steady state error for type 0, type 1 and type 2. So in type 0, type 1 and type 2, we are going to see type n system. So it can be 0, 1, 2, 3, etc. n. So in type n system, what you can see is g of s is equal to, so this is what you're going to see, g of s is equal to s plus, it's a general equation, okay? We are writing it for type n. So g of s is equal to s plus z1, s plus z2, etc. It will keep going, and s raised to n divided by s raised to n, s plus p1, s plus p2 in the denominator, etc. So this is how you are going to get it. So once you do that, now first we will focus upon the first type, that is type 0. So all of you should remember some of the basic equations. These equations will be useful for you when you take up the problems like ESS is equal to 1 by 1 plus Kp, and you know that Kp is limit of s tends to 0 g of s. All these things are required for you to understand. So we are going to just go with the type 0, the first type. So that is when you substitute, this is the general equation, and we are going to not, we are going to proceed with these three types, type 0, 1 and 2, and we are going to see that what are the equations for type 0, type 1 and type 2. So when you go with the type 0, we have n is equal to 0. Here n, it is type n system, so that is g of s is this one. When it is type 0, n will be equal to 0. So the equations what we get for a positional steady state error constant, and we get it as kp. Kp is limit of s tends to 0, s tends to 0, g of s, which is a constant. And we also get the equation for ESS as 1 by 1 plus Kp. So it's also a constant. So you should understand these things when we are going to study the steady state error. So we have to understand these things clearly. Just for you to come to the track, I will just go back and just say these things what we have studied in the previous class, because you need to study these things at every interval of time. So steady state error and error constants is what we are discussing. We are taking up a first order system, and we are going ahead with finding out the equations for that. So all these major equations we have done with it, and we got ES is equal to RS divided by 1 plus GS, and ESS is the final by using the final value theorem. We got ESS is equal to limit of S tends to 0, S into R of S divided by 1 plus G of S. First step what we have done is we have gone with the unit step function. So this is the first case where we have selected the unit step function, and all of you know that the equation for unit step function is R of t is equal to U of t. So by using the Laplace and all, you know that it will be 1 by S, and when you substitute and proceed further, you get it as ESS is equal to 1 by 1 plus Kp. Now we are going to use this ESS is equal to 1 by 1 plus Kp with the help of few things, like we are going to define few types. We are not going to define so many types, just type 0, type 1 and type 2 system we are going to see. So first we wrote for type n system. So this is the general equation for the type n system. So first let me proceed with type 0. So n will become 0. So when you go with the equation for Kp, you will get it as limit of S tends to 0, G of S, and it is a constant. ESS will be 1 by 1 plus Kp. Kp is there already here, limit of G of S, S tends to 0. So this is what it is, the equation for type 0. Similarly, we will see for type 1 and type 2. So you can just complete it, and then I will move on to type 1 and type 2 system as well. So I think all of you have completed till ESS is equal to 1 by 1 plus Kp. All of you have done with this now till here. In the previous class, all of you have completed till here, right?
Yes, sir.
Yes, sir.
Okay, then continue that with three types 0, 1 and 2, and then we will proceed with type 1 and type 2 system as well. So here one thing what you have to understand is we are now doing with unit step response. Okay, that is first case, and then we will do with the rest of the cases as well. So all of you completed. So is that completed?
Yes, sir.
Okay, we will proceed further with type 0 is over. Now we'll go with type 1 system. So let us see. So in type 1, so n will become, when it is type 1, n will become 1. And here the equation is Kp is equal to limit of G of S, S tends to 0. But there it is constant. When you do for type n system, Kp will be infinity. So here that is the thing what you have to understand here. In type 0, Kp will be constant. ESS also, when Kp is constant, automatically ESS also will go as constant when you substitute the here a constant value for Kp. So when it is type 1, Kp will become infinity, and when this Kp gets substituted in the equation for ESS 1 by infinity, so you will get it as 0. So ESS for type 1 system will be 0, and Kp will be infinity. Then we proceed further for n is equal to 2. So when you do that, see here the equation for GS is already written here. This is the equation for GS. So by using this equation, we are saying that it will go to constant and it will go to infinity and all those things. So when we go ahead with this one thing I want to just specify here, this Z1, Z2, Z3 are there, no, at the top numerator. This is all known as zeros, okay? And P1, P2 and all these things are, no, it is called as poles. So you will have poles and zeros. So in that all those things we have already studied before in the previous class as well. So I am not going too much into that. Then when you see the type 2 system, you can take it as n is equal to 2. And when n is equal to 2, when you go with the equation Kp, Kp will be infinity. And when infinity is substituted for ESS, so it will be 0. So you'll get for unit step response, you get three things. At type 0, Kp and ESS is constant. At type 1, Kp is infinity, ESS is 0. Type 2, Kp is infinity, ESS is 0. So now this is done with the unit step response. Now what is the next function? One of you. We have done with step response. Next function is which one? What are the three things we have studied? Step, unit step, then starting of this module. We called it as test signals and all those things.
Ramp function and parabolic function.
So let us go with case 2 or corollary 2 with a ramp function. Okay, now we are going to go with ramp function. So what is the equation for ramp function? Ramp function is defined using the equation R of t is equal to t u of t, and where u of t is the unit ramp function. So here, this case, we are going to go with ramp function. So whatever changes are there, that will be with respect to the equation R of t is equal to t u of t. All of it completed, then we will proceed with the second thing with ramp function. So when you take the Laplace transform for that, you get it as Laplace of R of t is R of s, and you know that it is 1 by s square. So I have been saying you repeatedly a few Laplace equations you need to know. Laplace and Laplace inverse, whatever it comes for control system. So we are not going to go beyond a certain limit with respect to Laplace and all very basic equations. It is good for you to just understand. So then we have R of s is equal to 1 by s square. Then we are going to see that the steady state error for a unit ramp input. So we are going to see that ESS is equal to, so steady state error can be calculated for a ramp input as ESS is equal to limit of s tends to 0, s into R of s divided by 1 plus g of s. Same equation what we have used it in the previous explanation. So here only thing is that the R of s term will be 1 by s square. So since it is a unit ramp function. So since it is a unit ramp function, you need to substitute 1 by s square there. So when you substitute it, you will get it as limit of s tends to 0, s into 1 by s square divided by 1 plus g of s is what you'll get. So s will get cancelled. It will be 1 divided by s into 1 plus g of s. So you will get it as 1 divided by s into g of s. So limit of s tends to 0. So why we have written, any one of you, can you say that why we have written S G of S? Let me know what you know about these limits and all in the mathematics. Why we have written S into G of S here? Because see here, the function E of S can be written as limit of S tends to 0, S into 1 by S square plus divided by 1 plus G of S. So since S is just tends to 0, so we have taken it as limit of 1 divided by S into G of S. So since S tends to 0, so when S is equal to means S is very close to 0, the function will change according to that. So ESS is written as limit of ESS for unit ramp response. So ESS you will be studying for 3 different cases. First one is you have studied for the step response. Now you are studying for ramp response. So for the ramp, ESS is 1 by S into the limit of S tends to 0, 1 by S into G of S, and it is 1 by kV. So you are going to get ESS is equal to 1 by kV. So what is kV? Can anyone of you say, by referring to the previous equation for Kp, can you say that what is the equation for Kv? Any one of you? Just try, nothing wrong in it. What will be Kv? See, all of you have completed till here. Have you all completed these things?
Yes, sir.
Type 2 and all, is that over? Type 2?
Yes, sir.
Okay. If you have not completed, 1 minute I'll give you. You just note down those things. We will proceed further. So all of you have completed, I hope so. So we will go with the equation for ESS. All of you have written the equation for ESS as well. 1 by kV. Have you all written ESS as 1 by kV? It's completed. Any clarification is required? Is that clear for all of you?
Yes, sir.
Okay, then let me know that what is the equation for kV. What will be the equation for kV? It is very much clear, no? In that it is there, no? What is kV? Limit of, what is kV? Limit of, see, respond. What is kV?
S to 0, sir. S tending to 0.
S tends to 0. What is further?
1 by
G of S.
S into
S
G
into
of
G of S.
S into G of S. So it is kV is equal to limit of S tends to 0, S into G of S. The velocity static error constant, it is called as velocity static error constant. That is the notation kV. So we are going to see the type 0, type 1 and type 2 system here. So first let us go ahead with type 0. So when you go for kV and substitute for type 0, so what you're going to get? You're going to get 0. So kV will be equal to 0. So what is ESS? What is ESS? kV is 0. What is ESS?
1 by 0, sir.
What is that?
Infinity,
1 by
sir.
0 is infinity. So ESS is equal to 1 by 0 and you'll get it as infinity. So type 0 system, you'll get kV is equal to 0 and ESS is equal to infinity. Then let us see that for type 1 system. Type 1 system, what is kV? kV will be a constant. kV will be a constant. What is ESS?
Constant, sir.
Yeah. So for type 1 system, kV will be a constant, ESS will be also a constant. So these things you need to remember for unit step function, how was Kp and ESS. For unit ramp function, how is Kv and ESS. So all these things for type 0, 1, 2, 3, you need to understand. So one more case, that is type 3, type 2. So when you go with type 2, kV will be infinity. When kV is infinity, what will be ESS?
Zero, sir.
Yeah. So you will get it as ESS is equal to 0. So these things you can just remember: type 0, type 1 and type 2, kV 0, ESS infinity, kV constant, ESS constant, kV infinity, ESS 0. So next you complete it, then we will proceed further. See, in the files folder, I have put lot of information for you. You can just go through it, and you can make use of it. Some videos are there. Even I have put a MATLAB tutorial. I hope so. If it is all those some examples are there, some even real time how the flight control is done using control system. There are a lot of things available in that. You can just go through it. Along with that, you can as well as see some question papers also I have put. All those things you can just look into those things. Okay. And if you want, you can just send to me, which can be included. We will include those things as well. If you find anything useful can be shared with all of your students, we can do that as well. So you need to increase your see, I have been saying you to do some extra problems and all. You need to increase your way of thinking. I think you need to be more competitive. That's very important for any placement related activities also. So try to be more dynamic and make use of your time properly. So these things we will come with the next thing. What is the third one? What you have completed with the ramp, you have completed with step as well. What is the next one?
Parabolic function.
Parabolic function. So what is the equation for parabolic function? What is the equation for parabolic function? See, study all these things. What is the equation? Any one of you?
1 by s cube.
Okay, that is correct. When I ask you the equation, you need to say that r of t is equal to t square divided by 2 u of t. And when you take the Laplace for that, you get 1 by s cube. So we are going to see the unit parabolic function, and r of s is equal to 1 by s cube. So you can do with the same manner. You have done anyhow 1 and 2 with the unit ramp and unit step. So let us proceed in the same way for ESS for this unit parabolic function. So steady state error for parabolic function. So what you have to do is you substitute for RS as 1 by s cube, and you will get very easily further because it is very easy to substitute and simplify. So you'll be getting 1 by s square will be left out, and rest of the terms will be there. So all of you can just complete it. So just I just want to check how many of you are actively participating in this class. So you can just raise your hands just for me to have a glance of that. Okay. Okay. Still don't make it down. Keep it raised. I want to see that how many of you are actively available in the classroom. So, okay, fine. Only 50% is available. So rest of them have just kept it on. Okay. So 23, 24. See, especially in control system or signal sense system, problematic subject, your presence is very important. It's not for others, not for your parents. It's for you. You have to make sure that you understand these things properly. So all of you can put your hands down. Thanks for your cooperation. Randomly, I will check for my satisfaction how many of you are really worried about the classes. So when we are going to substitute that s is r of s is equal to 1 by s cube, and you can see that when all this s and s gets cancelled, you will get it as limit of 1 by s square plus s square g of s, and you will get it as finally you can say that it will be 1 by ka. So you'll get it as 1 by limit of s tends to 0 s square g of s, and it will be 1 by ka. So here we are having the parameter ka with respect to the unit parabolic function when you simplify it further. So these steps you can complete it for the parabolic function, just simplification, and the limit of s square g of s is taken as 1 by ka. So k, what is the equation for ka is limit of s square g of s. Yeah, both of you can put your hands down. Amrutavalli, you can, if you don't have doubts, you can just let your hands down. Okay, okay, fine. Then we will continue further. All of you complete complete this portion. So we will see with respect to these things further. At least it's good that I can make sure that I'm going to get at least 25 to 30 students without any hesitation. They'll clear this paper. Okay. Uh, so all of you have completed this equation for ESS as 1 by K. Have you completed?
Yes, sir.
Okay.
Yes, sir.
Okay. We will proceed further then. So we will see that what are the different type 0, type 1 and type 2 responses for this unit parabolic function. So this also will complete it. So Ka will be limit of s tends to 0 s square g of s, and since you have already studied Kp and Kv, similarly Ka is called as the acceleration static error constant, and for type 0 Ka is 0, and when Ka will be 0, it will be 1 by 0, and ESS will be infinity. since we have studied all the three cases for other two, it's very easy for you to understand. Type 1, Ka is 0. When it is 1 by 0, you get ESS as infinity. And type 2 system, you complete it, then we will move on to the type 2. Type 2 also, you can see that Ka is constant. When Ka is constant, of course, ESS has to be a constant. So this is what they may ask you to write as a theory portion as well. Explain the steady state error and error constant for different test signals, that is ramp, step response, or parabolic response for type 0, type 1 and type 2 system. So like that theory, they can ask you to just write down all these things, or they will go with a problem where you need to find out all these things. So you can see that for type 2 system, Ka is a constant and ESS is also a constant. So here what you need to understand is Ka is called as the acceleration static error constant. See, assignment questions, what you need to do is solve those questions, compare with your friends. Don't think that you should not discuss. These assignments are given for you to discuss with your friends, come out with an answer, compare it with your friends. If there is any change over, you need to have a discussion among your friends. You select your good one or two friends and you have a discussion of that, whether the answer is correct or wrong. Then you upload it to the teams. Okay, we are giving assignments for you to interact, for you to have a open thought of mind, and you have to go with the things in internet and whatever materials are available. You have to go behind those things and find out how the solution has to be for that. So that is the reason we give assignments. So this much exposure has to be there before when you submit one assignment. So go through those things. So all of you have completed till type 1, type 2. Have you all completed till type 0, type 1 and type 2?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Just write down this problem. I will take this problem in the next class. You can just write down the question. So just write down this question. We will solve this problem in the next class. If you are trying to solve, you can go with that. Okay. There is no problem. You can just think of all these things, study and come all this whatever we have discussed today, and it will be easy for you to solve this problem further. So one of the problem is refer the unit negative feedback control system which is given. So here what you can see is g of s is given as 50 divided by s into s plus 5, and so this things is negative feedback system. So the following parameters are to be found, that is percentage overshoot for a unit step input, then settling time for a unit step input, and steady state error for an input defined by the polynomial r of t is equal to, this is given for you, 2 plus 40 plus 60 square. So you need to do this. So all of you can note down this problem. We will wind up for today. You can try solving it with all those things what you have learned. If means in the next class I'll be helping you out how to come out with the solution for this problem. Okay, so that's what we will wind up here with this problem. So all of you can just note down this problem and try for this how to solve it out with whatever you have studied.